please make Professor Jenny Couper welcome. Thank you.
Thank you, and thank you for inviting me, and congratulations everybody still being here. And I hope we'll keep things going and not tire you too much. So I've been asked to talk about how do we prevent type 1 diabetes in our modern environment, because as Nick has sort of mentioned, we're sort of aware now that type 1 diabetes isn't probably quite the same thing for everybody and isn't caused by quite the same thing for everybody. So I always like to start with a little bit of history, and this little girl on the right, some of you may have seen this slide before, was the first child in Australia to get insulin in 1922-23, just after it was discovered, and she actually died quite recently at 92 in Melbourne. So it's a very happy, wonderful story of a little girl. This is after the insulin. Now we know that basically before anybody gets type 1 diabetes, the insulin-producing cells have been destroyed, or at least patchily destroyed. We used to think they were just sort of wiped out completely, but we now know that it's quite patchy, and that is obviously very important with implications for really being able to help potentially at any time of a person with type 1 diabetes life. And as Nick has mentioned already this evening, which is good, is that one of the first sign we currently can be sure about knowing this is the start of this process is when in the blood you see these antibodies to the islets, this sort of islet antibodies, this islet autoimmunity. That's what Nick was talking about in his last talk. And we're used to thinking of diabetes being when you present to the doctor with the high blood sugars and often symptoms of thirst and peeing a lot and tiredness and other things. And that's what is now being looked at what we call stage 3. But we know that before that's happened for some time, usually years, the fate is cast, if you like, that the process has started. But we usually don't know about it till stage 3. So you can see from this slide, you start off with, pretty sure you're born with all your insulin-producing cells, but then something happens at some time, probably at different times of different people's lives, and you start destroying those cells. And for a while you can manage pretty well with only maybe half the cells, but eventually you get to a point where you can't manage as well and you get what we call diabetes, but it's the end of quite a long process. And this is a picture of some of the antibodies that you can use to sort of light up pictures of a pancreas, and that's showing us that the antibodies appear very early, and as Nick said, in some children as early as the first year of life. In fact, looking at children around the world, these are children from Europe and from US and Australia, antibodies occur in children, in the children who've got a family member with type 1 diabetes, that they're going to get them pretty early in life, usually under 3 years of age. And that means that we have to decide when this is all starting. Now, as you know, genes are important in type 1 diabetes. We know that, but we also know, as has been mentioned tonight, the environment's also very important. And the main reason we've been able to actually be sure about this is looking at how frequently people are getting type 1 diabetes. And these are different countries around the world, and we're in the straight line because we haven't had quite so many looks at our incidence in Australian children. But these are children under 15 years of age, and you can see that we've actually doubled our rate. So if you look at the line here to here, over the last 30 years in Australia, the rate of children getting type 1 diabetes has actually doubled, which is enormous, but not as enormous as Finland. And they've been following children since the 1950s in registers, and you can see they've increased sixfold. So it's quite dramatic, and it has to be something to do with the modern environment. Just a little bit of geography. So here is Finland, very high incidence of type 1 diabetes, really the highest in the world, as has been mentioned. And here is right next door, Karelia, which I never been to, don't know much about, but have to take it from the people that do know about them, that they're completely different countries in terms of their environments. But their genes are quite similar because it's just neighbouring. So the genes and the populations are similar, but their environments are quite different. And Karelia is more like what Finland was like before World War II, in terms of really quite a harsh environment, no processed foods, different sort of infections, and not as, in many ways, not necessarily as hygienic. So no one quite understands what exactly is different that really matters here, but there's something pretty amazingly different going on in their instance of type 1 diabetes. We know there are lots of risk genes in type 1 diabetes. Some are very important ones in the blue, but you can see how many there are. So you can sort of see what we mean by it being heterogeneous, and that means lots of different types and lots of different combinations of genes, and it's very likely that to prevent it, we're going to have things, some things for some people and some things for other people. Unfortunately, I don't think it's going to be one size fits all. Now, obviously, our environment has changed a lot over the last 20, 30 years. We eat excessive food. A good saying is we probably eat more than our grandparents did. and if you look at some of the serving plates they used, I had got my grandmother's dinner set when she died, and I thought, gosh, is that the plate? It looks awfully tiny. So we do realise that we have bigger serving sizes, we have more processed food, and we have different foods. We are probably not as physically active, because probably back in Victorian times you just had to be more active. We get a bit less sunlight because we use sun blockers, and rightly so. We're more hygienic. Caesarean section rates gone up. We're older when we have our children. We tend to be heavier when we have our children. We have more antibiotics and we have less sleep. Now, there's many things that there's no shortage of things that have been thought of that might be driving this increase. And to be completely honest, we have very few definite things here. A lot of them are still not sure. Now, Nick mentioned that people have been following children from birth at risk of type 1 diabetes, where someone in the family has type 1 diabetes or they have the genes which put them at risk of type 1 diabetes. And these have been in Finland, in US, in Germany, Australia. We've had one here, which we've done with Melbourne. And he mentioned TEDdy, which is the more recent one between US and Europe, and India is the one I'm going to talk about, which is our Australian one. India is across 5 states in Australia, but we lead it here from Adelaide. And what makes it unique and different from all the other studies in the world is we're going right back from pregnancy and following the baby from the pregnancy, as it were, before the baby's actually born. And there we are. There's the investigators and the hard-working coordinators who do all the recruitment and follow-up of the mums and their babies. So we're trying to follow, it's not a huge study by world terms, but a relatively small group of children where someone in the family has type 1 diabetes. That someone might be the mother who's pregnant, or it might be the father who has type 1 diabetes at home, or it might be a child at home. And to look at the effect of the genes, their growth, nutrition and viral infection on their bodies and the development of this islet autoimmunity, which in very young children frequently does lead eventually to type 1 diabetes. So it is a good way of actually working out what's going on. Now that's the little website there at the bottom, and we have videos and various things on that which help understand more clearly, more detail what it's about. Now, so the children are followed from the pregnancy through to 3 years and then beyond, but the sort of intensive follow-up, if you like, is in the first 3 years of life. And no other study in the world has followed children from as early as this. That's our sort of only reason why we've really been funded. And we have questionnaires for mothers and fathers and the little children. We have assessments. We have lots of different samples throughout that time. And it ends up being an awful lot of specimens from each participant. And so including skin swabs and all sorts of things, all very innocuous, but an awful lot. So we've got a big, big fridge with all these things going in. Oh, I'm sorry, I seem to be unable to move on now. Now, why are we doing this study when you've got a big one in US and Europe, you might say? You don't want to waste everybody's money. Well, we're actually looking at children where there's someone in the family with type 1 diabetes. The TEDdy study, which has been mentioned before, is looking at children mainly because their genes show them at high risk. So we're getting a wider variety of genes, which we think is important. We're following up, as I said, from early pregnancy. And the Australian population, interestingly, is likely to have different things that matter than the US and the European populations. We're just not quite the same, and I'll come to that, why that is. So I won't go, these slides without pictures are probably a bit heavy going at this time of the night, but what the big things we just simply don't know anywhere in the world is what's the pregnancy got to do with all of this? And it might not have very much, but it's kind of suspicious if children can get islet antibodies in the first year of life. So what are the big things going on in pregnancy that matter, and how can we, interfere and protect the child? And how do the genes of the children interact with their environments, and how do we compare with other populations in the world? So we start off with a little baby unborn, then the little child growing up, and then about 6% of these children, so a pretty small number, will develop islet antibodies, unfortunately putting them at high risk of developing type 1 diabetes. And Nick had talked about some of the nutritional things, and I think what I'm really trying to say here, there's been loads of things that have been raised, and some have more evidence than other. But actually, apart from congenital rubella, which has basically been wiped out, really, we don't have anything absolutely 100% sure that it definitely causes diabetes in the baby if you get it in pregnancy. Does that make sense? So it's the only definite thing, and we fortunately now have an immunisation program for that very reason, and other things that congenital rubella can cause. And so it's a long time since I've seen a child with type 1 diabetes due to congenital rubella, but 30 years ago we were seeing children like this. It was pretty rare now. But there are lots of different things, and we have things before the child's born, after the child's born, and we have things that once you've actually got the islet antibodies that might hurry up going to type 1 diabetes. What's most important, though, is what sort of things might protect, and I'll talk a little bit more about some of these things. Vitamin D is being looked at, and Nick mentioned the probiotics. The thing about that big study that he mentioned from TEDdy is that it was looking back, so the children were followed from about 6 months of age in that study, so they had to look back as to what their diet had been, and that's always a little bit of a worry because sometimes you don't quite get that accurate data you really want to do, but it's very exciting that something as simple as probiotics may help certainly some children. And some of the omega-3 fatty acids may be helpful, and it does look as though we think breastfeeding actually, in all the prospective studies, so the studies where we've followed children and watched them over time rather than look back over time, in all those studies breastfeeding hasn't been protective, including in the Australian studies, but it does look like when you start your child on solid foods, if you're breastfeeding at the same time, that is helpful. So it's sort of nuances. It's not, unfortunately, just barn door stuff. If you breastfeed, then you protect your child against type 1 diabetes. Life just, unfortunately, isn't as simple as that, as we know. And then we don't quite know how, once somebody's got autoimmunity, how to slow it down, and I'll come to that. There's been a lot of work on that. So we all know we're in a bit of an overweight epidemic, and we all probably, as I said, eat more than our grandparents and probably weigh a bit more than our grandparents, regardless of whether we're overweight or not. So we're all a little bit heavier than we probably would have been 100 years ago, and certainly heavier than we would have been 1,000 years ago when we had to hunt for our food and find it. Never mind. But it is interesting that throughout the Western world, the rise in type 1 diabetes does sort of parallel in those countries the overweight epidemic in children. I'm talking particularly in children now. And we know in our Australian data that very rapid weight gain in very early childhood seem to be a risk factor for getting islet antibodies in children at risk. We don't really know about the pregnancy weight gain and whether that matters. We do know about 50% of women now in Australia enter pregnancy overweight. So it's a pretty high lot of women, so it may be important in a few, but probably in the majority not. And we do know that once you've actually got those islet antibodies, if you've got a bit more insulin resistance, it might hurry things along a bit. Nick mentioned the study looking at cow's milk protein and whether after a baby's weaned from breastfeeding, and they looked in Finland to see whether removing the cow's milk protein from the infant formulae in the bottles helped protect against type 1 diabetes. This was an incredibly expensive study, $132 million, just to give you some idea of how expensive these studies are. So you don't want to set off unless you think they might help, because it's an awful lot of money to waste that time for those people too. And unfortunately, this study showed no benefit, which was very disappointing, because Finland really thought this might be one of the answers to their growing rate of type 1 diabetes. There's been a lot of talk about wheat and gluten, and babies obviously get their first gluten from their cereals. They first usually start with rice cereal, then they move on to gluten-containing cereals. And we don't actually quite know whether this matters, but there's some evidence that it's best to introduce the wheat-containing solids after 4 months and to breastfeed at the same time you're doing it. But again, it's not really definite information yet. Vitamin D is very tempting, because vitamin D is what we call an anti-inflammatory vitamin, and it seems to protect some things in the immune system. Certainly vitamin D has been linked to multiple sclerosis, and there's big work internationally and in Australia in relation to that, but no one has definitely linked it to type 1 diabetes at all, actually. And the way they're looking at it now, they can do these amazing things with genetic studies where they're looking at over 30,000 people's genes and the risk of type 1 diabetes in relation to their vitamin D genes, in a big study in US at the moment, and that probably will give us the answer in the next few years. So I think the verdict on vitamin D will come out soon, because we just got to know, because it's such a simple thing to do. But no one quite knows what the right level of vitamin D in pregnancy is yet. That we know what it is to protect bones, but we don't know for this type of thing, and we actually don't even know whether it can protect or not. So you can see it's complicated. Omega-3 fatty acids, these are what we call fish oils. That's why the fish is down there, just to remind me to say that. Again, there's been some information, like women in Norway, where there's a very high incidence of type 1 diabetes, women from fishing villages where they have a lot of cod liver oil, which has got these types of oils in it, and vitamin D, appear to have a lower risk of type 1 diabetes in their children, but no one has definitely shown that giving it helps. So there's a lot of work combining all the studies, combining all the food intake records, all the nutritional markers, and also looking at all the metabolites in their genes. So doing it in a very complex way, and that's also happening at the moment. Enteroviruses are what we call gut viruses, and we get them, we've all had them, we get them either we know we've got them when we've got a gut virus, or we actually don't know we've got them and we feel perfectly well. So we're getting infections, particularly when we're very young in life. Throughout the first year of life in particular, we get these infections all the time, and some the babies very well through. They have been seen at the time of getting those islet antibodies, and they have also been seen in the pancreas at the diagnosis of type 1 diabetes in some awful situations where someone died in a car crash or something like that, just very, very shortly after their diagnosis of type 1 diabetes, because we obviously normally don't look at the pancreas at the time of getting type 1 diabetes for obvious reasons. So it is a bit tempting that they're important in some people, and we're looking at all the genes in relation to them throughout the pregnancy and early life in the ENDIA study. So that is a pretty exciting area, and we're pretty excited with some of those early results, because that would be great to have some virus, at least for some people, because then you can actually immunise against that virus, and at least you've sorted it for some people. But why there's a lot of conflicting results in past studies, if you're probably sort of picking up from the way I'm mentioning things. And we used to think, 20 years ago, that if we just did a study from birth and watched babies, we could work out what the hell was going wrong and sort it. And here we are about 20 years later, and we haven't at all. And one of our research nurses at the Children's Hospital, Sarah Beresford, who first started working with me in 1991, which is actually now 25 years ago, she began with the thought that we were going to, we all thought in Australia then and the rest of the world, we're going to find what it was and sort it and treat it. And why have we struggled so much? And we think it's because there are interactions between our genes and the environment, and we've got some different genes. There are interactions between the environment and the environment. And so all these different things are interfering, if you like. So we think we haven't known quite enough about the people we've been studying. Our bodies are very complex, and they just seem to get more and more complex the more and more we understand about our bodies. And we do think that type 1 diabetes isn't exactly the same in everybody. You know, the reason we've got type 1 diabetes isn't the same. When you get these islet antibodies isn't the same. There's a group of children who get them very young. There are other people who get them a little bit later in their teenage years. And there are people, probably like Theresa May in England, who got type 1 diabetes in her 50s that probably got them in their 40s, you know what I mean? And some people even later than that. So it's simply not, and it's no way they all got the same reasons for getting type 1 diabetes. It just doesn't make sense, really. So that is the complexity of it. Now, Nick was talking about friendly bacteria, the healthy bacteria that live in our guts, and this is what we call them as the microbiome. That's the sort of scientific word, I guess, for all the genes we can look at for these. There are literally trillions of them. So we have trillions of bacteria all over us, all throughout our gut, everywhere, all of us. There are trillions and trillions and trillions of bacteria in the room at the moment, as I speak. But what's very interesting to paediatricians is these bacteria are reasonably stable in us as adults, but they're changing rapidly from birth through early childhood. And they seem to be very important in the way that our immune system develops, and they're affected by lots of different things, including the way we're born, whether it's vaginal or caesarean, what we first get to eat, when we get first fevers, antibiotics, you know, how long we breastfeed for, etc. And what's really exciting, as Nick has mentioned, is they can be altered by probiotics and with inulin, which he talked about, and with antibiotics as well. So that's a pretty exciting idea, because if they are kind of the key way some of our environment's working to give us type 1 diabetes through the effects on the immune system, that would be pretty exciting. And this is thought to be so big at the moment that Juvenile Diabetes Research Foundation, which is a big organisation run from New York, which looks at a lot of research in children's diabetes, has a whole consortium that we belong to just looking at the microbiome and type 1 diabetes. So it's pretty big at the moment, and I hope it's not all wrong, but it's pretty big at the moment. And this is just different colours for different types of bacteria, and you can see that this is pretty stable in adult life, but this is during the first 24 months of life. You can see it's really changing quite fast. These are normal, healthy children, nothing to do with type 1 diabetes. So this has been shown, and this sort of data is starting to come out now. These are big changes occurring in the first 2 years of life. And during the pregnancy, we have these bacteria throughout the body, in the mouth, in the placenta, that's right round the baby, and in the gut of the mother, and in the vagina. And there's been a lot of interest in relation to premature birth in these organisms and things like that. So this is all stuff that's sort of just coming out now in the last few years. It's all pretty new stuff. And we've shown the first studies in the gut microbiome in children who've got these islet antibodies. They are different from children without islet antibodies, but exactly what it means is still being sort of worked out. And we've sort of got very aware that we've got to be very, very, very good technically. You can get these enormous readouts of all these genes, and you can very, very quickly get completely the wrong result in an enormous complexity very, very fast. So one of the first studies we did in India was 6 lucky people provided their gut samples for 3 days in a row, and we looked at to make absolutely sure that technically we were really, really able to do all this, because there's a lot of excitement, but technically it can be easily mucked up and contaminated, as you can imagine. Now, just a little bit now about some of the actual intervention studies for people with islet autoimmunity who are at risk of type 1 diabetes, or maybe on their way to type 1 diabetes, and people actually with type 1 diabetes. And these studies are very hard to do in one country. Even in Australia, we're pretty small, really, because you need to screen, fortunately, thousands and thousands and thousands of people in order to get enough people who've actually got islet autoimmunity, which is good, that there aren't many people with islet autoimmunity out there, but it does mean there's been this big network of centres working towards the prevention of type 1 diabetes. And you can't just decide to do a study and go off and do it. You've got to register it with this global effort, because that's the only way we're going to get the answers before too long. And we also have a big genes consortium. Some of you may be involved in this. This is Grant Morahan's the person from Australia involved, but again, it's across Australia, Europe, UK, and South America and USA. This is not something that one little country puts up their hand to do. It's a global, and that's one of the exciting things about type 1 diabetes research. It's very global. We, even tomorrow morning, we have these terrible teleconferences at ungodly hours in the morning, but it's very exciting that we can talk to researchers around the world in our area, and it's all very lot of sharing of data, and I think it's been one of the great things about type 1 diabetes research. There was an intranasal insulin trial in Australia which came from Len Harrison's laboratory work in Melbourne, and this study has finished now. The people are still being followed in it, but what happened was there were two groups of children who were with autoimmunity who were at risk of type 1 diabetes, and one group had a spray into their nose with some insulin in it, which was the idea it would turn off the attack, and the other group had a sprayed into their nose some salty water, that there wasn't anything to do with a treatment. And both groups had a very, very low rate of type 1 diabetes, which is great, but of course it meant they couldn't separate the two groups at this stage, so that has not shown any results yet, that study. And that study just showed, I think there were 36,000 people screened for that study. It's enormous, the work for these studies. So you don't want to jump into a study willy-nilly without being pretty sure that you're going to try and help. We now have an approach, we work with, I'm not sort of feeling particularly pro-USA this week, but we work with US and with Europe and around the world globally to do prevention studies, because it's the only way we're going to get results. And this is a little picture of John Wentworth. I'm sure it's rather small, but he's got a rather small picture he sent me. And he is our Australian leader of these studies. And so if anybody's interested, I'm sure my email's somewhere. Yeah, and Sarah Beresford is our research nurse involved with these studies that we do from the Women's Children's Hospital. So for adults too, we're working with adult centres, so we can help these studies as well. So these are studies to try and turn off the autoimmune attack on the insulin-producing cells if you've actually got those islet antibodies. And then for those people who actually got diabetes within the last 100 days, we have similar studies as well, trying to slow down the immune attack and preserve some of the insulin-producing cells and hold on to that insulin production. It was, as you people with type 1 diabetes know so well, is so important for good control. It makes it so much easier if you've got some insulin production. But you might well say, but I've already got type 1 diabetes, and absolutely. But I think a really important point is that most people with type 1 diabetes still have some insulin-producing cells, but they're making such a tiny amount of insulin that it's just unhelpful. It's just a tiny fraction. But they've been able to measure this and shown that definitely these cells are making a tiny, tiny, tiny bit. And that gives some hope that if we understand how to, if you like, boost these cells, give them a tonic, preserve their function, then it's not just applicable to people who haven't quite got type 1 diabetes. It should be applicable to people actually with type 1 diabetes. So that's the sort of big excitement, that if we can sort of crack what's actually going on and how to protect those cells, we have cells which could be encouraged to start acting engaged. And that's a huge other area of research and sort of regeneration research. It is likely that different people need different agents, and that's a lot of the genetic work as well has been doing it as well. For example, Nick mentioned those probiotics. The babies who seemed to be helped with the probiotics had a particular gene type, so it wasn't all the babies at risk, it was a certain gene type. So it's that's the complexity which we're sort of grappling with. Thank you very much for all keeping awake.